So guys, we're gonna see how to calculate RSA private key and public key. First step is identifying P and Q. This is just a randomly chosen number. In this case, I have been pre-given these numbers, and this is our message. Just a spirit. Okay. The first case is you need to calculate n, and later use of n will be shown. 3 times 11 or p times q. This is not multiplied, just ignore this. And this will just be 33. Now you also need to calculate Euler-Tauschen function, but you can do this by calculating coprimes. But in this case, if you remember, you have 3 and 11, which are originally just prime, and you can do prime factorization, prime factor Euler-Tauschen by this method. P minus 1, Q minus 1. So you just get 2 times 10 is equal to 20. Now you have this and you have this. I'll explain the uses of this later. Now we have to approach and choose one public key value, which will just be any value that you want to find, but has to be coprime with this value, and it has to be less than this. So we can look for, let's call it an E value, and we can see for possible matches. So 1 out of 1 to 20 is not a possible match. It has to be greater than 1. So we can choose 2 to 20, 3 to 20. So this is eliminated. We cannot use 2 to 20 anyways. 3 to 20 is a possible match. I will use 3 to 20 because it's not prime with 20. So although I think you shouldn't use it because your original prime number is 3, but it doesn't really matter that much. So you would use 3 as your E. Now for D, where you would need the extended Euler function, this is how you'd approach it. You'd have to find dE mod n such that it equals to 1. So we'll replace our values. This is supposed to be 20, and we just chose our E, so this will just be 3. So something dE, 3 mod 20 such that it's equal to 1. You could do it by extending the Euler function. I'll show you how to do that now. I like to approach it in a different way than how the doctor shows it. 20 mod 3 is equal to 18. Let's just say 18. It will just become 18, by the way. It will just be 2. And then 3 mod 2 is equal to 1. I'm just writing this as the end of value that you would get, interior value from this. Now that we got the one that we need to see, we'd see and represent it in a different form. This could become 20 minus 3 times 6, which this is where the 18 comes from, is equal to 2. And then this I can represent as 3 minus 2 times 1, this is where the other 2 comes from, is equal to 1. Now I have this. How will I make this into R0 and R1, which I need it, and I'll show you what the point of that is. So this value will be your R0. This value will be R1 and S1. So how would you know the S1? So this value that you chose here is your R1. The value with this is S1, but I don't like to write S1 with it because you'd actually need to export it as a 6 itself, and then R2. This is the new value that you found. You have to find this value. It could either be here or here, depending on which one is greater, but usually R2 will just slide up here. R2, and this will be your S2, but since I did write this one, it doesn't really matter this one, because this is just going to be carried as is. And then 3 will just become, your 3 was R1, so R1, and then this is your R3. So now you can write it as this. R0 minus 6 R1 is equal to R2, and then you can write it as this. R1 minus R2 is equal to R3. And you can just do simple replacement in R3. R3 is equal to R1 minus R0 minus 6R1. Last thing is R1 minus R0 plus 6R1. You have to be careful here with the multiplication in this calculation because it's very easy to go wrong. So minus R0 plus 7R1 is equal to R3. So, I mean, as long as you come here to this point, you're correct, and you can check this out. You want only this value. You're not considering, you're not bothered with any other value. You look at 7, you take 7. 7 is the value I got here, by the way. You can check if your answer is right by 7 multiplied by, I think 3, because over here it was 3. You can do 7 multiplied by 3, mod 20. It will be equivalent to 1. This will be your E value, I think. No, sorry, your D value. D is equal to 7. So when you're in your public key, this is going to be your N in this case as well. Or you can, I'm not sure it's, oh yeah, so these are always your N, both of them. So this will just be 33, and I'll make this smaller just so everybody can see. The public part gets the coprime that's randomly chosen, 3, and this one gets the D that we just calculated, which is 7. This is it for this video. I'll make this smaller. In the next part I'll explain how to do encryption and decryption.